Okay, so we're going to solve a quadratic function by graphing. So roots, zeros, and solutions of a quadratic equation are also known as the x-intercepts of its graph. Therefore, finding the x-intercepts is one way of finding the solutions of a quadratic function. So we're going to use all the work we've done with graphing to help us find solutions of a quadratic equation or function. So we're solving now. So when we solve, there's three possible solutions of a quadratic equation that you'll see graphically. So the first situation is we have this quadratic here that's touching at one place on the x-axis. Remember, it's the x-intercepts, can also be the solutions. Therefore, this one has one real solution. This quadratic here touches in two places of the x-intercept, which means two real solutions. And then this one doesn't cross the x-axis, therefore there are no real solutions. Okay, so example 1, this one says we should have two real solutions. So let's go ahead and graph this. First things first, we want to get this in a form that we recognize, and we all feel quite comfortable with vertex form. A times the quantity x minus h squared plus k. This 3 is on the wrong side, so we have to move it over to the left. So we're going to have to subtract, and then we're left with 0 on the right. Now we have our h and our k. So at positive 4 and negative 3. So I have 4 and negative 3. If we're asked to find the table, we can just find two values below and two values above. So here we're going to plot this for negative 3, and then we need to use our a value, and our a value is 3, so that's a stretch that all the y values, all those heights over 1, up 1, over 2, up 4, and over 3, up 9 are all going to get multiplied by 3. So that over 1, up 1 becomes over 1 and up 3. 1, 2, 3. And the same to the left. The over 2 up 4 becomes 4 times 3, which is 12. So we go over 2 and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I can match it up on the left. And then this is our function graphed. Oh, having a hard time graphing today. Okay, so now we're looking for our solutions, and our solutions are going to be where it crosses the x-axis, and that is going to be our two x-intercepts. So it crosses at 3, 0 and 5, 0. So 3, 0 and 5, 0. Therefore, our solutions are 3 and 5. Notice how I have these in these braces. Let's go back and fill in some stuff here. It asks for standard form. So we get it into standard form by distributing this out. So we have 3 times x minus 4 times x minus 4. And that gives us x squared minus 8x plus 16 minus 3. So we have 3x squared. And we have 3 times 8, which is negative 24x. And then we have 3 times 16, which is positive 48 minus 3. So standard form becomes 3x squared minus 24x plus 45. And then if we put in each of these values into the equation, we will have 9 and 0. And then 0 and 9, and that's how we know our vertex is correct. Okay, a couple other things on here which are different from what we've done before. Interval where the graph is negative, so we're looking at the part where the graph is below the x-axis. The reason being is all these values down here, the y values are negative. So that's going to be between 3 and 5. So that interval, 3 to 5. Notice it's just less than 0, so between 3 and 5. Axis of symmetry, x equals 4. Y-intercept, well, we put 0 in. That's going to be 3 times 16. Minus 3, 48 minus 3, so the y-intercept is 0, 45. Domain, all real numbers, and range, lowest value is negative 3 to positive infinity. It's a minimum, and that minimum value is negative 3. And then the last piece here that's new as well is number and type. So there are 2 real solutions. Okay.